Next, we'll introduce the power and zero exponent rules in a similar manner, talking about where these rules come from. In example 3, what we have inside parentheses is a cubed, so a times a times a raised to the 4th power, meaning what we'll do is take that same expression multiplied by itself 4 times. So a times 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 a, and then one more time to get 4 factors of a times a times a. If we count all those up, what we have is a to the 12th power, a being multiplied by itself 12 times, which just so happens to be the same thing as a to the 3 times 4 power. So generalizing that pattern, anytime we have a to the m, so an exponential expression raised to another exponent, we can simplify or combine that by rewriting it as a to the m times n power. In example 4, we have a raised to the 0 power. We could think an example of this would be having something like a squared over a squared. Using the rule above, we know this would become a to the, sorry, not the rule above, jumping back up to the quotient rule, we know that this would become a to the 2 minus 2 power, which would become a to the 0 power, so these two statements are equivalent. But we also have the same expression divided by itself. So anything divided by itself is just going to become 1. So any value raised to the 0 power will always just be 1. The one exception, which we won't have to worry about for this class, is that we can't have 0 raised to the 0 power. But as long as a is not 0, anything raised to the 0 power automatically becomes 1.